Algebras. We are about to start Chapter 7, so this is the video for Chapter 7, Lesson 1. But before I get into Lesson 1, let me just review what we are going to be doing throughout Chapter 7 with you. So, Chapter 7 is titled Factoring Polynomials, and that is the plan. We are going to look at polynomials and different ways and look at for factoring opportunities, meaning breaking that polynomial into some pieces that are multiplied together, almost like undistributing is kind of how we'll think about it. Okay. So we're going to start with the three main types that we're going to look at, which is greatest common factoring, then difference of two squares factoring, then factoring trinomials. Okay. We will review, we will quiz, and then we will get into something called factoring completely, which will mean multiple steps of factoring occur. We're going to factor with trinomials where a is greater than 1, which will make sense when we get there. We will do a couple days of practice. And then we're going to have to factor completely a second time once we know that fourth type of factoring. Then there will be an exam review, and I will do a video encompassing each of those places that will be tested. And then, of course, our exam. Okay, so let me start with greatest common factoring, otherwise known as GCF. And throughout the rest of the year, I'm going to call this GCF. As you know, it's greatest common factor. That's what GCF stands for. Okay, now, one of the things that confuses people with GCF is when they hear greatest, they immediately think of the biggest number there. It's the biggest number that is capable of dividing evenly into all of the present pieces. Okay, so if there's only two pieces present, it's the biggest number that divides evenly into both pieces. So the greatest common factor of 18 and 45 isn't going to be a huge number like 45. It's going to be the biggest number that divides evenly in both. To find the GCF, you have to think about all the F's, all of the factors, right, in each term. So in the first term, it's 18, right? What are the factors of 18? Well, you've got 1 and 18. You got 2 and 9. You got 3 and 6. Okay, those are all the factors of 18. Now think of 45. And what are all the factors of 45? Well, you've got 1 and 45. No 2, right? 45 is not even. So 3 and 15. Okay. You've got not 4, 5, and 9. Okay. All your factors of 45. Now look at all the factors of 18 and all the factors of 45. And what is the biggest factor they have in common? That's the GCF. So notice they've got a couple factors in common. They've got 1 in common. They've got 3 in common. They've got 9 in common. What's the biggest factor they share in common? 9. The GCF of 18 and 45 is 9. Okay, let's do that again for 16 and 24, right? So factors of 16, 1 in itself is always a factor. Then, of course, 16 is even, so 2 and 8. And then not divisible by 3, so 4 and 4. So you only have to write it once. Now let's factor 24. Okay, so 24's factors, let's see, 1 in itself. 24 has a lot of factors. 2 and 12, because it's even. 3 and 8. Then 4 and 6. And notice as I was doing that, I came in together, and now I've got the full thing filled, right? I've got everything filled because those two numbers next to each other, it's not divisible by 7. There you are. Now let's look at the common factors and find the greatest common factor between the two. So common factor, common factor, common factor, common factor. What's the greatest common factor? 8. Okay, You try two factors of 42 and 70. I'll pause it and I'll come back. I'll start you off with both of them. Ready? Start you off. 1 and 42. 1 and 70. There you go. Okay? So you try that. Pause it. Come back. Hold on. All right. How'd you do? What's your GCF of 42 and 70? Yeah, they have 1 in common. Every number does. 2 in common. Yeah, they're both even. Okay, they have 7 in common. 14. The GCF of 42 and 70 is 14. Okay? Well, it turns out you can do the same thing with variables, right? Just real quick, before I head down to the procedure of factoring a polynomial using GCF, let me just remind you about how variables work for multiplication, right? X times X is X squared. All right? So that means that X squared has factors. X squared has factors of 1 and itself, and X and X. And so you could conceivably pull an X or an X squared out of having that variable present, X squared present, right? So that means that there are things that can divide out of a variable as well. That is what we're going to be doing with our GCF for polynomials, okay? What we're going to do is we're going to look at our 2 or our 3 or our 4, however many terms we have, and we're going to look at all their numbers, and we're going to see if there's a GCF for the number. Then we're going to look at their variables. Okay, if X is one of their variables, is there an X in common in all of the terms? Is there a Y in common in all of the terms? And that's what we're going to pull out. We're going to divide all those terms by the GCF and leave a leftover. So that GCF is going to be that number out in front of a set of parentheses. The GCF is the result if you undistribute something, right? That's the front of that set of parentheses. So that's what we're going to be doing here, okay? Think about, what do all of these terms have in common? What can they all divide evenly by? And then when I do that, what's the leftover? All right, so here's an example. Down here, we have, of course, this example that we have right in our notes with the procedure, right? But here's another example of that happening, right? If I'm asked to factor 24x cubed minus 16x squared plus 8x, I look at 24 and negative 16 and 8, and I think, well, what are they all evenly divisible by? And then I look at x cubed and x squared and x, and I say, what factor do they all have in common? Okay, and that's what I pull out, and then I divide each term by that factor, by that full GCF. So between a 24x cubed, a negative 16x squared, and an 8x, all of those things are evenly divisible by 8x. 24x cubed divided by 8x, well, 24 divided by 8 is 3. X cubed divided by x is x squared. That's the first term in the leftover. Now take negative 16x squared divided by 8x. Negative 16 divided by 8 is negative 2. X squared divided by x is x. Then, lastly, any term divided by itself leaves a 1. That's where I get the leftover pieces. The GCF, the thing that all of those was divisible by, is left up front. The leftover has the same number of terms as the original polynomial, because any number divided by itself will always leave a 1. So they'll always be the same number of terms as the original polynomial. Let's just do examples. It helps a lot to just do lots of examples. So that's what I'm going to plan to do, right? So between an 18x and a negative 27, what do they have in common? A 9. So that means 9 is my GCF. Now I divide each term by 9. 18x divided by 9 is 2x. Negative 27 divided by 9 is minus 3. Undistributed. Between a 6x and a negative 36, what do they have in common? A 6. 6x divided by 6 is a 1x, or just x left over. Negative 36 divided by 6, negative 6 left over. GCF on the outside, set of parentheses, leftovers on the inside. Same number of terms as the original polynomial. 20xy minus 5x. Okay, between a 20 and a 5, they are both evenly divisible by 5. So that's the number part. X, Y, and X. Well, do they both have an X? Yes. How many do they both have? Only one. So that's the most that can come out is 1. Do they both have a Y? No. Y is not part of the GCF then. They're not both evenly divisible by Y. So 5x is my GCF. Now I divide each term by 5x. So 20xy divided by 5x. Well, 20 divided by 5 is 4. X over x cancels out to a 1. 4 times 1 is still 4. And y can't be divided by anything else there, so it is remaining with that 4. Negative 5x divided by a 5x, well, that leaves a negative 1 behind. Okay? Let's try this again. And then I can tell you what a simpler rule is for the exponents, right, on your variables. So x to the 5th, y squared, plus x to the 3rd, y squared. Definitely two separate terms because they have, while they have the same variables, they're not all raised to the same exponent, so they have to remain two separate terms. How many total x's are here? 5. How many here? 3. So what's the most number I can pull out? 3. So x to the 3rd is what's part of the GCF. How many y's are here? 2. How many y's are here? 2. What's the most number of y's I can pull out? 2. So y squared goes here. The smallest present number on your variable is what goes into the GCF. Out of the two x's, 3 was the smallest present, so that's the one I can pull. Out of the two y variables, 2 was the smallest present, that's what I can pull. And then that's how we work it. So now, 5 minus 3 is 2, and y squared divided by y squared is just a 1. Then over here, wait a minute, this entire term and that entire term are the same, so divided by itself, it's a 1 left over. Anything divided by itself leaves a 1. Here's another place where that can work, right? Let's think about it. 5x cubed minus 15x squared. 5 and 15 are both evenly divisible by 5. What's the most number of x's I can pull here? 3. What's the most number of x's I can pull here? 2. So what's the total most number I can pull? 2. It's the lowest present exponent. That's the most number I can pull out of both. So 5x cubed divided by 5x squared. 5's cancel out to a 1, dividing the 5's. 3 minus 2 is 1, so x to the 1st is left. Negative 15 divided by 5 is negative 3. The x squareds cancel to a 1. Negative 3 times 1 is still negative 3. That 1 left over gets absorbed by the number that's already present. Okay, between a 7x squared y and a 14xy and a 28x, they're all divisible by 7. There is not a y in everything, so it cannot be part of the GCF. There is at least one x in every term, so that can be part of the GCF, right? X to the 1st is the lowest present exponent in all the terms. So now 7 cancels out to a 1. X squared divided by x is x and not divisible by y. 14xy divided by 7x, well, that's 2y. And 28x divided by 7x, that's a plus 4 remaining. Okay, I'm going to pause it, see how you do on 7, 8, 9, 10, 11 on your own. Try those, and then we'll come back and just do one more compare contrast, okay? Okay, how'd we do? On number 7, there is no common number that can come out, which is fine, but there are a common amount of x's that can come out, right? On number 11, you could pull the negative and now all the signs of the leftover are positive, or you could leave all the signs of the leftover negative by only pulling a positive 6y. Either one is fine when it comes to that part. That's a choice on your behalf. Okay, so just a couple of things, but make sure you got those correct. Look through my answer key. This is a great place to pause. Look through my answers for those that you were trying on your own. See what I did. Again, remember, the smallest present exponent for all of the terms is the amount of that variable you can pull out. So in number 10, I could not bring an x out as part of the GCF. It was not in this last term. There was no x in that term. It cannot be part of the GCF. Okay? All right. So what's the difference between what we were doing in chapter 6 and what we're doing in chapter 7? Well, in chapter 6, we had that number on the outside of the parentheses and we distributed it, right? In chapter 7, we're going backwards with that. We're coming backwards. We're pulling that piece back out with the leftover. We're pulling that piece back out of each of those terms with the leftover left behind. Okay? That's what we're doing in chapter 7. So it's undistributing. We're undistributing and going backwards with those. Okay, algebras, good luck. Do that homework practice right now. Make sure you have all these written down with me. Make sure you're taking the notes with me. Make sure you're using the notes to help you as you work on the homework. I will be seeing you. Ask me for help if you need it. Good luck. Have fun.